Good morning, dear student. Today I will discuss shifting property of inverse transformation. First I will discuss first shifting theory of inverse transformation. First shifting property of inverse Laplace transformation. First, L inverse f s plus a is equal to e to the power minus at ft. This is a first shifting property of inverse Laplace transformation, and second shifting property of inverse Laplace transformation L e to the power as f s is equal to f t minus a into u t minus a. This is the second shifting property of Laplace transformation. Now I am discuss few numerical of these properties. First I have solved find the inverse Laplace of L inverse 5s plus 3 total upon s minus 1 s square plus 2s plus 5. Solution of this question: let 5s plus 3 upon s minus 1 s square plus 2s plus 5. First I have write to breaks partial fraction. Now breaks a upon s minus 1 plus bs plus c total upon s square plus 2s or plus 5 plus 5. Now comparing both sides, 5s plus 3 is equal to a s square plus 2s plus 5 plus bs plus c s minus 1. Now 5s plus 3 is equal to a plus b s square plus 2a minus b plus c s plus 5a minus c. Now comparing variable and non-variable, then a plus b is equal to 0. Now a is equal to minus b. Now again 2a minus b minus c is equal to 5 and 5a minus c is equal to 3. Now solve this. When putting a is equal to 1, putting a is equal to 1, then b is equal to minus 1. Therefore, putting the value of a, this means 5 into 1 minus c is equal to 3. This means c is equal to 2. Let equation number first. In equation first, put the value of a, b and c. Now break 5s plus 3 total upon s minus 1 s square plus 2s plus 5 is equal to 1 upon s minus 1 plus, put the value of b is equal to minus s plus c is equal to 2 total upon s square plus 2s plus 5. Now taking L inverse, this means inverse Laplace. This means inverse Laplace of 5s plus 3 total upon s minus 1 s square plus 2s plus 5 is equal to L inverse of 1 upon s minus 1 plus L inverse of minus s minus 2 total upon s square plus 2s plus 5. Now I solve this. I will put to this function. Now next is L inverse of 1 upon s minus 1 minus L inverse of s minus 2 total upon s square plus 2s plus 5. Now solve this. E to the power t is a function of e to the power t minus L inverse of, to break this function, s plus 1 minus 3 total upon s plus 1 to the power 2 plus 2 to the square. Now break this function. E to the power t minus e to the power minus t L inverse s minus 3 total upon s square plus 2 square. Now break this function. E to the power t minus e to the power minus t L inverse of s upon s square plus 2 square minus 3 L inverse of 1 upon s square plus 2 square. Now open the inverse Laplace e to the power. Now again e to the power t minus e to the power minus t bracket. This is a function of cos 80. This means 2t minus 3 upon 2 1 upon a. This is a function of sin 80 sin 2t. You also write e to the power t minus e to the power minus t. This means minus minus plus into 3 by 2 sin 2t minus e to the power minus t into cos 2t. This is your final answer. Please note down to this numerical. If you have any query, please you contact me, or otherwise find the value of inverse Laplace 1 upon s square plus a square to the whole power 2. Solution of this numerical. Solution of this numerical. First, let inverse transformation of 1 upon s square plus a square to the power 2 is equal to break this function, inverse function of 1 upon s square plus a square. We have 1 upon a sin 80. Now differential with respect to a. If I have differentiated this equation, now you find L inverse d upon dA 1 upon s square plus a square is equal to d upon dA 1 upon a into sin 80. Now differentiate to this function. First, u upon v. This means L inverse minus 2a upon s square plus a square to the whole power 2, and this is a function of u into v. This means 1 upon a cos 80 into t plus sin 80 into this differential is minus 1 upon a square. Now you write this inverse Laplace of minus 2a total upon s square plus a square to the power 2 is equal to t by a cos 80 minus 1 upon a square sin 80. Now you solve this. Therefore, L inverse 1 upon s square plus a square to the power 2 is equal to 1 upon 2a cube sin 80 minus p upon 2a square cos 80. This is your final answer. This to find the value of inverse Laplace of s upon s square plus 6s plus 25. Solution of this inverse function: L inverse of s total upon s square plus 6s plus 25. First, you write this function. To solve the quadratic equation s square, you write s square plus 6s plus 9 plus 16. This means L inverse of only s total upon s plus 3 to the power 2 plus 4 to the power 2. Now you break system. L inverse of, you adding and subtracting, plus 3 and minus 3. S plus 3 minus 3 total upon s plus 3 to the power 2 plus 4 to the power 2. Now again solve inverse Laplace of this function s plus 3 total upon s plus 3 to the power 2 plus 4 to the power 2 minus 3 L inverse of 1 upon s plus 3 to the power 2 plus 4 to the power 2. Now again solve. This is a function of cos inverse e to the power minus 3t L inverse of s square plus 4 to the power 2 minus 3 e to the power minus 3t inverse Laplace of 1 upon s square plus 4 to the power 2. Now this is a function of cos 80 and this is a function of 1 upon a sin 80. It means e to the power minus 3t cos 4t minus 3 by 4 e to the power minus 3t into sin 4t. This is your final answer. Now you can note down this numerical, and please like and subscribe this also to my channel. If you have any query, please contact